Hello everybody, Bob Giglio back in my workshop to do another video. And this is going to be the last video I'm going to do on my router table. I've already done two parts of this video. This is the third part and final part. The first part, you saw me modify my porta cable router so that I could use it as a lift with working with this Craig plate here that you also saw me install. The second part was the tabletop, the butcher block here for the router table. And now the third part is going to be the cabinet. So this cabinet here, I made out of MDF about 40 years ago. It served its purpose well. It's very simple. I just have a big compartment here for the router to sit within. I have a couple of drawers. It worked fine, not a problem. I made it out of scrap material I had hanging around the shop a long time ago. So now it's time for an upgrade. So I just want to take a step back and review the cabinets I made and the differences in them. So here is a traditional one, set of cabinets I made that has the full front face to it and the traditional overlay drawers, not full overlay. This is a very nice cabinet construction, so all the faces are really finished well. And then I moved on to more like these types of cabinets, which are made completely out of 3/4 inch, like a birch face plywood. They don't have any sort of front face to them. So if you see here, they're just the edges of the plywood sheets here. So, and the nice thing about these cabinets is, from an efficiency point of view, here's another one for my drill press. You can get the biggest drawers because you have the face frame is not there, and you can make the drawer a little bit bigger and it gives you the maximum space efficiency out of a particular cabinet size. And I do like the way they look. They're very simple, very clean looking cabinets, where this is more ornate and has more of a design feature to it. And I've kind of like progressed my thinking, at least the shop type cabinets. I'm gonna build the router cabinet out of this style here, this design here, which is basically a full no face frame on the front of the cabinet, and the doors are basically full overlay. So I have the minimum space between the drawer fronts. To get started, I kind of went through and I inventoried what I want to go inside of the new cabinet. You know, the things I have, like my bits, my zero clearance inserts for my router fence, my template pieces, gauge pieces for setting up bits, and also attachments for the fence, and to change the bits, tools to change the bits. I got some couple routers, portable routers in here. I'd like all that to go into the new cabinet, okay? So I figured out my drawer sizes, what they have to be. And then what I did was I made a nice sketch like this. There's a lot of detail in here, but you don't have to really get into too much of it at this point, because we just want to know the size of the cabinet here, how many compartments it's going to have, and the depth of it, so that it fits nicely with underneath the existing butcher block top I have. Now determine the panel sizes I'm going to make, the partition, both the outside panel for the cabinet as well as the partition pieces within in the cabinet. So, and from that, I can then work up these cut sheets for a piece of plywood. I'm using 3/4 inch birch face plywood in this project. And now I can go ahead and size out the pieces and how they would lay out on a 4x8 sheet of plywood, so I get the maximum efficiency from that, the minimum waste out of cutting this plywood. I went ahead and started to rip the big pieces down and cross-cut them outside using a guide saw, a circular saw on a guide. And now we're going to go ahead and use my table saw and my miter saw to go ahead and finish cutting them down even further. Here the panels all cut to the proper size. And as you saw me cutting them, some of the tools that became very important to me was the first one was this crosscut sled. After I ripped the big pieces with the fence on this table saw, I then added the crosscut sled, and that gave me very accurate crosscut square cuts on the panel pieces, which is very important for a cabinet. I use as well my miter saw to make crosscuts accurately, but this can only handle 12-inch wide boards at max. I did cheat on a couple of them. As you saw, I cut a 2-foot panel on this by flipping it over twice, and then what I do is I finished it up on the to get a nice straight cut on the sled. The next step in the project is to start cutting the dados into each of the cabinet pieces. So as you see here, I have a center shelf here, or center partition piece here that goes throughout the entire cabinet. So we're going to cut the dados into each of the side pieces first, and then we're going to cut the dado into the horizontal shelf piece, and then on the bottom, and then the two on the top. So what I did was I set up my blade, my dado blade here for 3/4 of an inch. I measured the thickness of the plywood exactly. I went ahead and did a dado stack to equal the thickness, a little bit of clearance, and I cut a test piece, as you can see here, and I put the test piece on here, checked it for depth and size, and it fits good. So we're going to go ahead and cut these dados. With the panels cut and most of the dados cut, I went ahead and fit up the cabinet pieces, as you see here, and just to make sure everything fits right, and to actually mark out the dado cuts, I'm gonna put it in the back plate to receive the partition pieces. So in my cabinet designs, I like using the full thickness 3/4 inch back panel for the cabinet. That ensures the cabinet is going to always be square and very strong, and it will really resist racking. So that's why I do that. I marked out the locations of the dados in the back panel of the cabinet, as you can see here. And because they're not through dados, and I have to stop the board before I go into cutting into areas where I don't need a dado, what I did was I put 2 marks on my fence here that I lined up with the front of the blade, where the front of the cutting of the blade will be. So I know when to stop. So when I'm right before getting into this dado here, I'm just going to cut until I get right to this edge, and then I'm going to use a chisel to go ahead and finish the cut, a sharp wood chisel on both ends. So here's a lesson learned I picked up on this project. You just see that I have a lot of tear out on this one dado cut here into the shelf piece. And the reason for that was I had to reduce the size of the dado because I had mixed plywood in this project, which I don't like doing. These panels are a little bit thinner than these panels. So what I did is I reduced the dado stack to accommodate that. And when I did that, I did not adjust my zero clearance insert here, and that caused the tear out. So what my quick and easy fix was I just took the insert, instead of cutting a new one and reducing the size, I just glued in a popsicle stick here. You can see it like here, and then I put it back in and I let the blade trim it to zero clearance. That's a little bit thinner than the previous one. So that's how I solved that problem. The next step in the project is to miter the side panels and the bottom panel into the back panel. As you see here, I just butt them together now, but what we're going to do is we're going to cut a joint like this. It's called a lock miter joint, and it has, basically, it's a miter joint with a tab in it, and once you glue this together, it's very strong. And what I love about this joint is that the finish of the material you're using is uninterrupted as it goes around the bend or the angle. So you never see the end grain, and it's a very strong joint. I went ahead and set up my router table with the bit to cut that joint. It's right here. And I do use a zero clearance insert with this because as you've seen in my last project, I had some tear out problems when I used this bit, so this solved the problem. And to set it up, basically, I set the height of it and the fence so that this template that I've cut with a very similar close piece of plywood to what we're using now, I set it so that, as you can see here, fits very nicely. It's cutting at the right position, both height-wise and depth-wise. And so I set it up like this, as you can see. And now we're going to do a test cut with the exact material that we're using on our cabinet project to make sure that we get a good joint. So after a couple of cuts and some minor adjustments on the fence, you see now I'm getting an exactly perfect joint here. So we're going to go ahead and cut the panels on our piece. And this time I put a spacer in here, basically to do the cut in 2 steps, because this takes a lot of material off. One thing I want to mention is that we have to cut these in a particular order. So one piece, as you saw me cut, was against the fence, and I marked that with an F, and the other is against the table. In other words, you always have to make a joint with one fence and one table cut. So in knowing that, you can then decide as you build the cabinet which face will be cut with the fence and which will be cut by the table, and that's why I marked them here. If you can make out, I put an F and T to make sure the joints are always opposing each other. And for the order, I like to sit things into the joint, so when I glue them up, like in this case, I want the back panel to be against the fence, because I get this nice cut here that I can then sit the side walls and the bottom into. So this is one of the side pieces, and when you cut the side pieces, it's going to be a little bit different, only in the fact that this is the top of the cabinet, which is going to be open, except for I'm going to put 2 stretches in on the front, on the top, so that it has structural strength this way. So what these router cuts here only go in about 6 inches is marked here. So we're gonna do a partial cut for these 2. This is along the back side, bottom side. They're going to be a full table cut as marked. With all the cuts, the minor cuts done now, I'm going to go around and clean up the cuts. And as you saw, with big panels like this, it can be a little challenging to make sure the panel is properly positioned against the router bit. So as you saw, I also used some feather boards to keep the panel nice and tight against the cutting blade. Still, I get a little bit of deviation on a couple of these joints. I'm just going to sand them out a little bit, and use a chisel to make sure they're nice, all and even. And then we're going to go ahead and dry fit everything. So the next step in our cabinet project is to now consider what we're going to do for dust control in this center compartment where the router is going to sit. So of course you have to have an inlet for the vacuum connection. So here it is. I basically just took a coupler, a hose coupler, put it in here with a couple of spaces to move it away from the wall and the floor, and I just traced out the opening for the vacuum hole, which I'm going to drill. So then I thought, well, how can I prevent or clean up the chips that are left in the corners? And based on all the very good videos I saw online and my experience in the shop, the corners is where the chips will settle, and you can't get them out. So I came up with this half pipe idea, like you see here traced out. And this way there won't be any corners. It'll be like just a half pipe, and on the bottom of the half pipe, I'm gonna drill, route it in slots. And on the underside of the half pipe will be a negative pressure caused by the vacuum, and that hopefully will suck out the chips as they come down into the bottom of the pipe and then just get sucked out through the bottom. That's my idea. Let's see if it's going to work. It's definitely an experiment. So how did I draw that arc? So one of the things I wanted to make sure was I had a minimum clearance here of 1 inch, so that I have enough clearance so that the chips will fall through the slot and then out here in this negative area and out through the vacuum. That's how I set this bottom of the pipe. On the sides, I just went up what looked good, about 6 inches on each side. And then what I did was I basically, knowing that this distance here was 14 inches, then I got the center point of 7 inches here, and I set my trusty, unusual looking compass with an extension that I used to use in my drafting class when I was going to engineering school. So what I did was I set this radius here for 7 inches, and then I just found that center point and just went ahead and traced out the arc you see here. So some of the considerations was I wanted to make sure I had enough meat between the curvature of the pipe and the opening for the vacuum. You see that's good enough, I think. And now what I'm going to do is I'm going to cut some panels or some plywood blocks to fit in here, and then I'm going to trace out the arc like you see here on probably 3, maybe 4 of them, and that would be the support ribs for my half pipe. And then on top of that, I'm going to attach this masonite, this piece of masonite here, which hopefully will be flexible enough to make that bend or that radius, and we'll give it a try. So with the ribs cut and drilled, as you can see, we're ready now to lay a piece of that masonite on top of the ribs. So now we're going to do just a simple calculation here. So you see I drilled the 2 1/4 inch hole here to receive the vacuum hose. Then here I drilled a little bit bigger one, and I cut the bottom out of the opening so that I have really more flow area here than there, because as the further you get away from the vacuum source, the lower the vacuum will be because of all the losses through these ribs. So because of that, I opened up, and the other reason I did that was so that I no dust will settle underneath here, so that it'll always be clean. So now we have to think about the slot. So what I did was I just did some simple math. I figured out the area of this opening here, the 2 1/4 inch. And for a typical circle, it's a very simple formula. It's basically just pi squared, and I just, knowing the 2 1/4, I worked out the formula. It comes out about 4 square inches of area. And because I have roughly 9 inches between each of the ribs here, then I'm going to put in 2 slots 9 inches long. The question is how wide should they be to match that area, and just backing it out, taking the 4 square inches, dividing it by the 18, which is the 9 plus 9, you come out with about a 1/4 inch slot. So that's how I figured that out. And now I'm going to go ahead and lay this piece of masonite into on top of the ribs. And to help me figure out the cut size of the piece, I went ahead and I got a piece of this thin foam, which is very, very pliable, flexible, and now I kind of cut it to size, trimmed it so that I know exactly the size of the piece of masonite I'm going to cut. With the masonite cut, I drew a center line to mark the location of the slot. And as you saw me, I drilled 4 pilot holes at the end of each slot. The slot's size, what I did was I just marked out where the ribs were going to be. This is the beginning rib, the middle rib, and the end rib. So now I know my end points on the slot. I configured my table saw with my 1/4 inch dado blade, just 2 end blades to get a 1/4 inch width. And now I'm going to run the blade through just a portion of the slot. How I know when to start and stop, I had marked on my fence here a start line of where the blade begins to cut and an end line where it stops the cut. So if based on those lines, I'm going to guide the piece against the fence and start it and stop it so that I end up right at the point of where these pilot holes are. So after cleaning up the slots with a file, as you saw, I have the piece now just about almost ready to go in, but I noticed that it's still very stiff. This is a very stiff piece and it's gonna not bend well. So what I'm gonna do is I'm gonna cut some relief cuts on the back side to make it more flexible. And I set up in my table saw the thinnest curved blade I could find. It's less than 1/8 of an inch. So we're going to use this, and I'm just going to cut a series of grooves in the back side of the panel to relieve the stiffness and make it more flexible. The piece with the curves cut into it, it is more flexible now, still kind of stiff, and I did break off these tabs as I was doing it, so no problem. We're going to put it back anyways with the truss supports, the ribs will hold everything together. Anyways, the last thing to do now is I'm going to cut 45s at each of the end where they meet the wall, because it does not meet the wall straight. And what I did for that was I set up my router table with a 45 cutting bit here, edge bit, and I set a fence up. So here it is installed, well, just placed inside the cabinet. As you can see, it fits nicely. I went ahead and I put my router in place, and I lowered it to the lowest possible point to make sure everything fit okay. I mocked it up with a tabletop spacer blocks up there. So it looks good. I'm very happy with it. You can see in here, right there is the vacuum right through to the back. So in each chamber is going to have a negative pressure to it, and hopefully it will work well. I opened the slot a little wider because, like I said, I was a little concerned about the chips, the bigger chips going through. Now the only last 2 details I have to do right now is I have to drill a hole, get this power cord out of there, and then I decided to put a switch here, a safety start-stop switch here, and then I'm going to use some cord covers to cover that. The other thing I have to do is drill the holes for the casters on the cabinet, and then we're going to go ahead and do a finish sanding to all the panels, and then glue them up. So here's the cabinet all glued up and clamped. We'll let it sit overnight, and we'll come back in the morning and start to work on the finish now. I don't usually use nails or pins when I assemble my cabinets. It's just, I know I use a lot of clamps, but I don't have to get my pneumatic nailer out and start nailing panels together as I glue them. So I choose this method instead. So let's talk about painting the interior of this cabinet. So I'm doing this to seal the wood. Really, I don't want any mold to grow on the wood or dirt to get into the wood, and it makes it hard to clean it or to keep it clean. So what I did here is I used a primer, a Zinsser water-based primer. That's a kind of a universal primer. You can go over anything with it, latex or enamel or alkali, oil-based. So I first put this down, as you saw, with a roller, and I brushed in the corners, cut in with the brush. This is a challenging space to paint because to spray it would be nice, but I'm gonna get a lot of spray back on me if I did this, because there's really nowhere for the spray to go. And it's gonna be very tough to get the gun into some of these tight spaces, especially here and here. So I decided to roll it and brush it, as you saw. And now I'm going to go through and just cut down, sand between coats with the sanding pad, between coat sanding pad. It's like a 00 fineness, just to knock down any bumps or smooth out the primer anywhere I can. And so then I'm going to go over it with this enamel. I had this Benjamin Moore enamel in stock. It is a light color enamel, which is what I wanted for the inside, because this compartment in particular is where the router is going to sit. So I do want to be able to have a lot of brightness in it so I can see my router. Any of the settings I have to set on it, speed, depth, anything like that. So I wanted it to be bright. So I'm going to go over all the compartments with this enamel, and that will be a good finish for me inside here, as well as, even though you won't see them in the drawer spaces, to keep it, just to seal it. Here's the cabinet now with the one coat of the oil-based enamel on it. Remember, it was the Benjamin Moore and Pervo enamel. It looks pretty good. I don't think I'm going to do anything more other than this center compartment. I'm going to do one more coat of the enamel because I got a little bit of, I want an extra finish here because we're going to be seeing this. The other compartments are going to be with the drawers, so I just did it to seal it. And what I ended up doing with this, it was very difficult to paint with a roller or a brush, so I did spray this with my spraying equipment, and it came out pretty good, I must say. So it looks really good. Outside of the cabinet, we're going to go ahead and put a primer coat on it. I'm going to use this Fresh Start. I had it in stock. It is tinted for the darker paint finishes. So I'm going to use for the finish, I'm going to use this Emerald Sherwin-Williams paint. It's urethane trim enamel. I've had good luck with this. You've seen me use this in my cabinets before. I've sprayed this. I rolled it. This time here, I'm going to go ahead and roll it onto the cabinet. and we're gonna see how it goes. I'm gonna put 2 coats on and we'll see what it looks like. So with the primer coat on, looks like a nice even coat. I'm just going to go over it with a inner coat sanding pad, and just gonna knock down any of the bumps, smooth it out a little bit, and then we're gonna apply the first finish coat. So here's the first coat of finish. It came out pretty good, not perfect. And now we're gonna do a second coat. We're gonna sand between coat. Here's the cabinet all finished with 2 coats of enamel, urethane enamel on the outside, and 1 coat on the inside of another enamel, Benjamin Moore, and this compartment for the router, I did 2 coats in there because you will see that. The other ones are just for the drawer openings. The last thing we need to do with this cabinet is to go ahead and install the casters. I went out and bought these heavy-duty casters here, and I'll be installing 6 of them. I pre-drilled the holes. I put a set in the middle as well, you see here, so to make sure the cabinet never sags. So I'm going to use these 14 by 3/4 inch screws with a hex head on them. I'm going to use a little bit of grease, screw wax, to help the screws go in. Okay, so here it is, all done. The cabinet's all done. As you can see, the casters are on it. Came out really nice. And what I did was I made sure that this was not permanently installed, so you can pull this out and like this and push it back in, so it gives you the flexibility of changing out the baffle or modifying it, you know, to make it work better. Okay, now we're going to end this part of the video, part 3. I'm going to make a part 4 now, just to show you how I build all the drawers in the front of the cabinet now.